Hey, so I just finished up doing the double replacement reactions, and now I'm going to move on to doing single replacement reactions. It's not as complex as double replacement because double replacement you have the three equations that go along with it, and having to figure out whether or not there's the precipitate and spectrate ions and all that. So I'm going to be doing number 10, and this is one of the word ones and already has the products and word for you, and you have to convert it back into chemical formulas. So iron metal, so Fe, which it implies that it's a solid because it's a metal, reacts with aqueous silver nitrate, so plus aqueous silver nitrate yields aqueous iron 3 nitrate, so FeNO3 3 aqueous, and then plus silver metal, so Ag, solid. So now we have to balance them, and we have to get 3 nitrates on the reactant side, so put a 3 here. And now the nitrates are balanced, and now since we have 3 silvers on this side and then 1 on this side, we put a 3 here. And the equation is now balanced. So just gonna explain this really quick. It's pretty easy because you're just putting the words into chemical formula, so you don't have to predict anything. But iron is replacing silver, so that it becomes iron nitrate and then plus silver. So you will have to look at your activity series just to see whether or not if you have an element plus a compound in a single replacement reaction, whether or not it can replace it, because some elements are so reactive that other elements can't replace it in a reaction, so then there would be no reaction. But in this case, a reaction does happen, and the iron does replace silver. So I'm going to do one more single replacement reaction because it seems that most people get it, but I just wanted to reiterate everything. So I'm going to do 27. Number 27. Okay, so this is words, and you have to convert back into chemical formulas and then predict the products as well. So we have solid aluminum, so Al, solid, plus aqueous sulfuric acid, and just to note, acids are aqueous, so if you see an acid and you're not sure of like a hydrochloric acid or sulfuric acid, etc., they're aqueous. If you don't have like the state symbols or anything, just to note that. And then yield, we have to predict the products now. So the aluminum is going to kick out the hydrogen, so it's going to be Al2SO4 3 aqueous, and then plus H2. So now we have to balance it. So there's 3 sulfates on this side, and we have to make the reactants have 3 sulfates, so we add a 3 here. And now we have 6 hydrogens right here and 2 on this side, so now we have to have a 3 here to balance them out. And then 2 aluminums. 2 aluminums on the reactant side and 2 aluminums on the product side. So this reaction does happen. The aluminum can kick out the hydrogen. And I'm trying to think, where is my... The reason why aluminum sulfate is aqueous is because most Most sulfates are soluble in water, so they don't form a precipitate. But I just wanted to note that there are exceptions for whether or not sulfates dissociate or dissolve in water. So some of the exceptions are barium sulfate, lead sulfate, silver sulfate, and then strontium sulfate. So those are the 4 that are exceptions. They do form precipitate when paired with a sulfate. They're just exceptions, but anything else like aluminum sulfate does not form precipitate. So that's the end of that one, and I'm going to go on to synthesis next.